Hi, how's it going? Welcome to Code with Z. In today's video, we have to convert this array that we have here into a binary search tree. Why are we doing this? Well, because that's what LeetCode 108, convert sorted array to binary search tree, is asking us to do. As you can see, it says, given an integer array called nums, for example, this array that we have here, where the elements are sorted in ascending order, as you can see, it is sorted, converted to a height balanced binary search tree. So let's see how we can solve this. First of all, let's see how binary search trees even function. So for example, this is a binary search tree and its rules are really simple. We're gonna have a root or a parent node, and anything to the left side of it has to be smaller than the parent, and anything on the right side of it has to be greater than the parent. As you can see, 3 is smaller than 6, and 9 is greater than 6. And this rule applies to the children nodes as well. So for example, if this had some children, all of the nodes to its left side have to be smaller than the parent, and all of the nodes on the right side have to be greater than the parent. So for example, we're gonna have 1 and 4. And because of this structure, everything on the left side is gonna be smaller than its parent, and everything on the right side is gonna be greater than its parent. So that's gonna be our simple rule. Everything on the left side has to be smaller than the parent, and anything that we have on the right side has to be greater than the parent. Now that we know how binary search trees function, let's see how we can convert this into a binary search tree. Well, we're kind of lucky because our array is already sorted, and this is gonna help us to easily convert it into a binary search tree. But where we start from is really important, because if you remember, everything depends on the element that we start from, because all of the elements on the left side have to be smaller and all of the elements on the right side have to be greater. So it really matters where we start from. So for example, if we start from this -10, everything has to go to its right because it's the smallest element inside of the array. So we need to make sure that we start correctly. And we can do this by just simply starting from the middle. This is already sorted, so if we pick the element in the middle, we can easily put all of the numbers that come before it to the left side and all of the numbers that come after it to its right side. So if we actually find the middle of this array, that's gonna be 0. If we get the length of this array divided by 2, that's gonna give us the index of 0, and this is gonna be the element that we're gonna pick as our root node. And then after we've done that, we can easily say these are the numbers on its left side. Basically, these are the numbers that have to go to the left side here, so they are going to be the nodes on the left side, and these are the numbers and the nodes that are greater than 0, so they have to go to the right side. So we already took care of 0. For the rest of these, believe it or not, you've already seen what we're going to do. We're simply going to repeat the same thing for this side and this side separately. So what do I mean by this? When we started, we found the element in the middle, we turned that into a node, and we were like, okay, let's find the elements on its left side and all of the elements on its right side. So we're gonna do the same thing. We're gonna be like, okay, we have 2 elements here, 1, 2. Let's find the middle between these two. 2 divided by 2, that's gonna give us 1. So the element with the index of 1 is gonna be this -3. So this means this element has to come first, and we're gonna turn it into a node. Now, if something is foggy, don't worry, because we're gonna have more explanation. So for example, we're gonna call the same function on these 2 this time, and we're just gonna treat these 2 as an individual array. We have 2 elements, and we need to find the middle element. Well, 2 divided by 2, that's gonna give us 1, and the element with the index of 1 is gonna be this 9 here. So we're gonna be like, okay, we found the middle, so let's just put this here. And then after this, we're gonna be like, okay, we're already done with -3 and 9. We're gonna call the function for the remaining numbers. As you can see, each time we call the function, we find the middle element, we're gonna fuse it to its parent, and we keep on calling the function until we reach a point where we've already been through all of the elements inside of the array. So for example, this time, the element on the left side is gonna be -10, so that's gonna be the middle element because that's the only element that we have on the left side. So we're just gonna fuse it to here. Simple as that. And then same thing for 5. It's the only element that's left on the right side. So we're going to turn it into a node and fuse it to its parent, and that's going to be it. And would you look at that? We have a binary search tree, and we went through all of the elements and the numbers that we had here. That's going to be it. Now let's code this in the simplest way possible. Alrighty, let's solve this together. So the very first thing that we're going to need is to find the middle in our array. So we're going to say const mid is going to be equal to nums.length divided by 2. Nums is the array that we were given, and we're going to divide the length of that array by 2 to find the middle. But because we don't want to have any decimals, we're going to say math.floor. So that, for example, if we get 3.5, we're just going to get 3 instead. After we've found the middle, we're going to get the value in that position and turn it into a node. So we're going to say const root, that's going to be new tree node with the value of nums at the index of middle. And you might be like, where did we get that tree node from? Well, that was given to us by the question. As you can see, each time we initiate it, we make a new node that's going to have a value property, a left property, and a right property. After we've found the root, we're going to call the function again in this style. We're going to say root.left is equal to the same function that we have here, but instead of nums, we're going to call it on nums.slice from 0 all the way till middle. And this is not going to include the middle. So we're calling the same function on the left side of the middle, and we're going to call it again on the right side. So we're going to say sorted array to BST. And this time we're going to say nums.slice from middle plus 1 all the way till the end. And then we're going to return our root at the end. And this is going to be it. But let me explain this one more time. So what we're doing is that we're going to make a node when we find the middle, and then we're going to call the function on the left side of that middle. And we're going to say whatever you return, that's going to be your left. And then we're going to call that function on the right side of the middle. And we're going to say whatever you return, that's going to be the right. So the right side of the parent node. And then at the end, we're going to return our root. But what if our nums is empty? Meaning if we were given an empty array. Well, if that was the case, we're going to say if nums.length is equal to 0, just return null, because we can't have a tree. So we're just going to return null. And I made a small typo here. This has to be an uppercase T. Now let's run this and see if we can actually get accepted. And we got accepted. Now let's submit this and see if we can actually pass all of the test cases. Moment of truth, and we got accepted. That's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.